So, like I said, the last time I saw you, we talked about completing the square and we found where the quadratic formula came from, right? We completed the square on, we took our ax squared plus bx plus c equals 0, and we completed the square on this, right? On the standard form of the equation. And what we came up with was the quadratic formula where we had the x equals minus b plus or minus b squared minus 4ac over 2a. And this is right here the quadratic formula. And a while back, I told you that there are two ways that will solve every formula. There are two things that will solve every single quadratic equation under the sun, right? One is completing the square, and the other is the quadratic formula. Because really, the quadratic formula is just the end result of completing the square, right? If we plug in all the numbers, all we have to do is simplify. It takes us to the solution. It gives us our x equals. This part of the formula is the solution, right? We just have to plug in the numbers and then simplify it. So today what we're going to do is we're going to solve a lot of quadratic equations using the quadratic formula. And there are some steps, right? Because you guys seem to like steps. I have students that really like when I list steps to do something. So steps for solving quadratic formula. It's really using the quadratic formula, not solving the quadratic formula. Number one, write quadratic equation, whatever quadratic equation you are trying to solve. Equation in standard form. What is the standard form? This up here, this ax squared plus bx plus c equals 0. Basically, put them in order, set it equal to 0, right? Step 2, identify A, B, and C, right? They aren't going to be A, B, and C. They're going to be actual numbers. And plug into formula. We could say substitute in if we want to be formal. But basically, we're just... So whatever our A, B, and C are in here, we're just going to plug in as A, B, and C where you see them here. And 3, simplify / solve, right? We're finding our solutions. And that's it. Those are the only 3 steps. What we are going to do today is we're going to take this formula and we're just going to use it like crazy. We're going to do it on all sorts of problems. Our first one will make fairly basic, but we are going to just do as many of these as I can throw at you so that you can see different options of equations before we get done here today. I will do them till I get tired of doing them. So will we go the whole class? Probably not. So if I have x squared plus 2x minus 63 equals 0, we are already in the standard form. We have our ax squared, our bx, and our c, and we are set equal to 0. So we're already in the standard form of this equation, right? We don't need to write the standard form of the equation because we've already got it written. So we're going to move on to step 2, which is we are just going to identify our A, B, and C, and we are going to plug them into our formula, which is, again, in case you forgot, minus B plus or minus B squared minus 4 times A times C equals 2 over A, right? That's the formula. I'll write it again and again. In this case, we don't have anything in front of that x squared, so our A term is just 1. In front of our x, we have a 2. And our constant at the end here is just negative 63. So we know what our A is, we know what our B is, we know what our C is. If any of these except for A doesn't exist, like if we don't have an X term or we don't have a C term, we can still solve it, right? Our B term would just be 0 or our C term would be 0. If our A term is 0, it's not a quadratic. You got to have that X squared or it's not a quadratic. So we're just going to plug these in now. We know our formula. Our formula is minus B. Well, that's just minus 2 plus or minus the square root of B squared. So that is 2 squared minus 4 times A, which is 1, and times C, which is negative 63, all over 2 times A. And again, A is just 1. And so we've plugged everything in, and notice that over here in the formula, we no longer have letters. Everything is a numerical value. Now we just have to simplify it, and we will know what our X values are. We should have 2 values because of this plus or minus. Occasionally, it'll be 1 value, and you'll see that in a little bit. I always like to solve what is under the square root first. So I'm just going to leave my minus 2 plus or minus alone for right now because it's PEMDAS. It's sort of like a grouping, whatever's under that square root. And I know that 2 squared is 4. And if I look at negative 4 times 1, I get negative 4 times negative 63 is going to be positive 252. And I know that off the top of my head because I'm brilliant or because I just did it in 4th period. But if you want to think it's because I'm brilliant, go right ahead. And so if I look at this now, I've got minus 2 plus or minus the square root. If I add 4 and 252, I have 256 all over 2. Are you following? Now, if we look at this, luckily for us, 256 is a perfect square. It's not always going to be a perfect square. But in this instance, 16 squared, 16 times 16 equals 256, right? So I can pull this out as minus 2 plus or minus 16 over 2. And if you remember, I said that's 2 solutions, right? It's negative 2 plus 16, right? Which is 14 divided by 2, which is 7. Or negative 2 minus 16, which is negative 8. And negative 18. And when we divide that by 2, we get negative 9. These are our solutions. These are our X equals. And what they represent is if I were to graph this equation, right? This quadratic, what it's saying is that where we are going to cross the x-axis with this is I'll have a point at negative 9, and I will have a point here at 7, right? And I know that this quadratic of mine is going to cross like that at those 2 points. That's what that's telling me, right? You'll learn later on that we can also find things like the vertex and all that within it. The vertex is either our high point or our low point. In this case, it would be a low point, right? That turning point. But ultimately, what we're learning is that we're finding those solutions. And the solutions of a quadratic, we always say, are those points where it crosses the x-axis. Same thing with any polynomial. Like if we moved on to something to the third or fourth or fifth power, right, our solutions would still be where we're crossing the x-axis. And you'll hear them called all sorts of things, roots and zeros and intercepts and solutions, but ultimately that's what we're talking about, where we're crossing the x-axis on a graph. Which is why we set it equal to 0 in the first place, because what is x? What are points on the x-axis, but where we have a number value for x, but y equals 0, right? We're not going up off of the line. Anything on this line has a y value of 0. Did that make a little bit of sense? Okay, cool. So let's look at another problem. We'll do it in another color. I feel like my markers are really skinny today. Maybe that's why. Maybe because we're on like 60% right there. We need 100%. So let's look at another example. That's much better. Minus x squared plus 2x equals 1. So if we look at this problem, it doesn't look like too big of a problem, but we're not set equal to 0. So the first thing that we have to do is set this up to the standard form. We want it set equal to 0, right? Not equal to 1. And so what I'm going to do is I'm just going to subtract 1 from both sides and then rewrite the problem. And we'll have negative x squared plus 2x minus 1 equals 0. So now we're in the standard form of the equation. Now we can use this a little bit better, right? So what we have to do now is we have to find our x values by plugging them into the minus b plus or minus b squared minus 4ac over 2a, right? And so what we're going to do is we're going to identify what our a, b, and c are. And in this case, if we look at it, a equals, well, it's whatever is in front of this x squared. And all we have right now is a negative there. But that really just means negative 1. If there was nothing in front of that x squared, it would be 1. But because there's a negative there, it's negative 1. Our b is what is in front of our x value. So that is just 2. And then our c doesn't have any kind of an x attached to it at all, right? It's just our constant number, which is also negative 1. And so now we're going to plug them into the formula. Wherever we see b, we're going to put in 2. Wherever we see a, we're going to put in negative 1. And wherever we have a c, we're going to put in negative 1. So we're going to go x equals minus b. Well, that's just minus 2 plus or minus 2 squared. I get in the habit of anything I'm substituting in to put in parentheses, because if I have a negative, I don't want it to look like minus, like I'm subtracting 2. I want to make sure that you understand that those two things are together. Minus 4 times a, well, that's a times negative 1 times c, which is also negative 1, all over 2a. So all over 2 times negative 1. Right? And now we just simplify and solve. And again, always deal with this grouping right here first. So I have minus times 2. I'm just going to write that as minus 2. If I was plugging in a negative 2, that would become a positive. Plus or minus, and we're going to deal again with what's under here. 2 squared is just 4. I have a negative times a negative makes a positive, times a negative makes a negative, right? If I have an even number of negatives being multiplied, it becomes positive. If I have an odd number of negatives being multiplied, it stays negative. But if you don't know it, just look at it. Go, okay, I've got -4 times -1. That's positive. And when I multiply that times another -1, it's negative. So I know whatever comes in here is going to be negative. -4 times -1 is +4 times -1 is -4. And you're noticing maybe that we have 4 minus 4 under that square root. 2 times -1 is -2. So I have -2 plus or minus the square root of 4 minus 4. Well, that's just 0 all over -2. What is the square root of 0? Yeah, go ahead. Make sure and watch the video, though. Okay, America? What is the square root of 0? Right, Grace. It's just 0, right? 0 times 0 equals 0. Nothing else times 0 is over -2. So really, this just goes away, right? Because whether I'm adding or subtracting 0, it makes no difference, right? That part goes away. And so I'm really just left with -2 over -2, which is just 1. Notice we only have one solution this time, right? We have x equals 1. That is the solution. Does anyone remember what we talked about when we were talking about how sometimes you'd only have one solution? And I told you what it represented at one point. I know it's kind of a stretch to remember that one. Does anyone remember what it would look like on a graph? Okay. Well, on the last one, I graphed it and I told you solutions meant it's where the graph crosses the x-axis, right? And at this point, it's only going to cross at one point, right? Say this is 1 right here. This is where it's going to cross at 1. It just means, in this case, we have a -x, so it's going to go down. It just means that our vertex, our either high or low point, our minimum or maximum, is the point that's on the x-axis, right? And so it'll only cross at one point because the sides aren't coming out. It's that turning point that is sitting on the x-axis. And so that's why you would only have one solution in this case. And later this week, we'll talk about opportunities where we don't have any real number solutions, where they're imaginary and stuff like that, and how they cross. But for today, this is all we need to know. Trying to look at what I did on the board next. Ooh, I like this one. What if I have a different color? 9x squared minus 1 equals 24. Now notice there's no x term. If we wanted to, we could use square roots to solve this. But because we're working on the quadratic formula, we're going to go ahead and use the quadratic formula to solve it. And so like before, we're going to move over this 24 so that we're set equal to 0. We're going to do that by just subtracting 24 from both sides. And we wind up with 9x squared minus 25 equals 0. If you looked at that also, you could go, ooh, that's a difference of squares if you remember that far back. But you don't have to, because a quadratic formula will solve it in any form whatsoever as long as it's quadratic. So we're going to identify our a, b, and c. In this case, our a, whatever is in front of x squared, is just 9. Our b, well, we don't have an x term here, so our b is just 0. Our c is whatever doesn't have an x, and in this case, that is going to be -25. And so now we're going to go ahead and we're going to plug that into our formula, our minus b plus or minus the square root of b squared minus 4 times a times c over 2 times a, right? And we're just going to plug those in. So we've got minus b. Well, that's really just minus 0. plus or minus b squared. Well, that's just 0 squared. Minus 4 times a is 9 times negative 25. That's our c. All over 2 times a, which is 2 times 9. And notice the math just got easier because anytime you have a bunch of zeros, if you have zeros and ones, your math gets easier. So it's always nice to have a 0. And now we're just going to solve this. Well, negative 0 is just 0. So what are we looking at? We're looking at plus or minus the square root of 0 squared. Well, that's also just 0, right? So 0 minus 4 times 9 times negative 25 is just going to be whatever this equals. When I look at this, I go, well, 4 times 25 is 100 times 9 is 900. So I'm going to have the square root of 900 over 2 times 9, which is just 18. Now, I could look at that and I could go, I see 4 times 25, I know it's 100. And if I multiply it by 9, I have 900. If you don't look at that, you don't see that, plug it into a calculator. There's nothing wrong with using a calculator, right? Lucky for us, 900 is a perfect square. It's 30 times 30. So what we have here is plus or minus 30 over 18, right? And that is a fraction. Reduce that fraction, right? We are going to have plus or minus. Each of these are divisible by 6. If you don't know that, start with dividing them each by 2, right? 30 and 18 are even numbers. If you don't know they're each divisible by 6 or 3 or whatever, start with 2 and then reduce the next piece. And I know that they're both divisible by 6. 30 divided by 6 is 5, and 18 divided by 6 is 3. This is both our solutions. It's positive 5/3 and it's negative 5/3, right? If I were graphing it, which I will fake graph it right now, right? Say I have 1 here, 2 here, 1, -1 here, -2 here. I would say that 5/3 is what? 1 2/3. So it's going to be like here on this side and here on that side. And it's going to go something like that, right? And it's going to cross both those paths. Make some sense? I know I graph them a lot and you're probably bored with that, but I just want you to remember that that's what we're looking at. These are the solutions we're looking for. Where is it crossing that graph? Let's look at one more. I want to find one, hopefully, with a somewhat imaginary solution. I didn't work out all of these problems that I printed. So I'm going to do one more problem. Either we'll have an imaginary solution out of it or we won't. Or a complex one that doesn't break up into a perfect square so that you can see how that works. And then I'll let you go. I'm going to go for one of these on the bottom because I figure the higher the problem number, the more likely it is to be complicated. So I'm going to go minus 3x squared plus 8x minus 7 equals 0. We are already in the standard form of this equation. We're already set equal to 0. And so we're going to identify our A, B, and C. Our A is -3. Our B equals 8. And our C equals -7. And we are just going to plug that into x equals minus b plus or minus b squared minus 4ac over 2a. Right, so we get x equals, well, minus b is just minus 8 plus or minus the square root of b squared. Well, that's just 8 squared minus 4 times -3 times -7. all over 2 times a, which is 2 times -3. So all we're doing is plugging the numbers in. Where we have a, b, and c, we're plugging in whatever. Ooh, that was weird. We're plugging in whatever our a, b, and c is. And now we're just going to go ahead and simplify. We have our -8 plus or minus, and we're going to work on the square root. Well, 8 squared is 8 times 8, which is 64. Well, minus, I'm trying to think of the best way to do this. Minus 4 times 3 is plus 12. And then we're going to have 12 times -7. What's 12 times 7? 12 times 7 is, I can't even remember my times tables today. 84. 12 times 7, 84. Okay, I like this because this one's going to have all sorts of stuff right here. Over -6. So when we go to simplify this, we've got -8 plus or minus the square root of -20. Does anyone remember how to deal with a negative underneath that? Maya does. How do I deal with the negative, Maya? For 1.5 million bonus points that happen to be imaginary. It's a lowercase letter, right? I think you know. If we have a negative under the square root, we can just pull it out as an I. Remember? So I could rewrite this as -8 plus or minus I times the square root of 20 over -6. Do you remember that? Now, the issue with this is we still have to break up that square root of 20, right? And if I take 20, well, it's 4 times 5. 4 is a perfect square, right? It's 2 times 2. So I could pull the 2 out. The 5 doesn't have a match. So I'm winding up with -8 plus or minus 2i times the square root of 5 over -6. A lot, I know, and we're still not done yet. Everything here is divisible by 2. So -8 divided by 2 is -4, plus or minus 2i times the square root of 5 divided by 2 is just I times the square root of 5. -6 divided by 2 is just -3. Now we're done, right? I told you this would be a complex solution, right? What did we have? We had a square root that didn't break all the way down. It wasn't a perfect square. We had an imaginary number underneath the, we had a negative underneath the square root, which gives us the imaginary number. This had everything that could possibly be ugly in it, right? Is this our solution? Yes, right? Can we break it down further than that? No, we can't. Do I want some crazy decimal that you plug into a calculator? No. Is this 2 separate solutions? Absolutely. This is -4 plus I radical 5 over -3, and it is also -4 minus I radical 5 over -3, right? It's just that plus and minus saves us from having to do it over and over and over again. Would you do the same if you had just one negative? I'm not sure what you mean, just one negative. In which part? Like, because this is negative and this is negative? 8 would be, well, in this case, if the 8 was negative, we would have still had positive 64 because we're squaring that negative. We did it because when we had this 64 minus 84, the total was negative, right? So we were left with negative 20. If we were going 84 minus 64, then it would have been a positive 20, and we would have just had to break down the square root. There wouldn't have been an imaginary. So anytime when you finish all of the math underneath this square root, if your answer is negative, you just have to pull it out as an I, and then it's positive. Did that help? Was that helpful, the explanation? Okay. So I've showed you some simpler ones. I've showed you the hardest one you'll probably have to come across as far as the type of problem you're going to solve. So I think we did a fairly good job of like covering the gamut of types of problems. Remember this, your homework is in Delta Math. You don't have to show me work in Delta Math, right? But when it comes time to take the test or quiz or whatever we get to, you're going to have to solve them out. So make sure when you're doing the Delta Math that you actually know how to do them, okay? Because it will really, really help you down the road, because this may not be the last math class you ever take, right? And so you definitely need to know how to do these stepping stones that get you to the next one. But that is all I have for you as in terms of the lesson itself. So I'm going to stop the recording, and that way, if you guys have any questions, you can go ahead and ask them. Otherwise, we'll let you go a couple minutes early today.